Hi, my name is Rick Sherman, and I have something that I want to share. Ever since I was a kid, I've been pretty much immersed in nature in one way or another, growing up in western Montana. I had the opportunity of spending time in the city of Great Falls growing up, and also along the headwaters of the Blackfoot River. It became pretty obvious to me where I felt most comfortable. And then when I was 10, my father bought a packing outfit in Spotted Bear on the north end of the Bob Marshall Wilderness. And I spent the next 4 summers packing on horseback into the South Fork of the Flathead and experiencing deep nature ecology on a level that very few people actually get a chance to experience. That affected me, and it's guided the trajectory of my life ever since. By the time I was 17, I pretty much had decided that what society was laying out for me wasn't what I wanted to do. The 9 to 5s, the regular job, the family, the house, all of the physical and material trappings of affluence that we have been taught that we need and want and desire. I kind of let that go at some point and started drifting off looking for an alternative. I traveled around the country on a motorcycle for most of my 20s. But early on, I stumbled onto a labor co-op called Hodads out of Eugene, Oregon. And spent the next 6 to 8 years, I think it was, traveling around the Northwest planting trees, climbing trees, building fences, thinning, working the woods, doing what I thought was stewardship. I thought I was putting the trees back. I thought I was doing something that was good. Somewhere along the line, I realized I was just planting a row crop, a monoculture of Doug firs that were destined to just become, likely toilet paper, houses and such. And then I had the opportunity to plant Mount St. Helens after the blast, after the mountain went off and leveled many square miles of old growth forest. They had us planting willows on the lower areas and the drainages, deciduous trees, berry producers, bushes, brush. Had firs on the north slopes and pines on the south slopes. It was the first time that I actually did a restoration, and I understood, and I got it, and I continued to search from there. I spent the rest of my life from then looking for alternatives, living in various kinds of communities, intentional and unintentional, since then. And finally, in 2008, I joined with 9 other people after 4 years of planning and searching for land, and bought 40 acres of land in western Montana, not far from Missoula, Montana, and started Sundog Eco Village. I had found what I had searched for. I found a collective where people could pool their resources, pool their energies, pool their passions, and make things happen. I was the one with the experience in forestry, so I took on the forestry projects, since it was 40 acres of forest, and dealt with pine beetle infestations and spruce budworm infestations. I did some studying, I did some research, I talked to a lot of people, I took classes, and I found that we can have a positive impact on the lands we live on. We thinned, we cut the big trees out that were full of beetles. We brought that land back. The work that we did actually had a positive impact. The land was better off for the efforts that we did. It was the first time that I've really seen that we could actually have a positive impact on the lands that we live in. Unfortunately, that project only lasted for 5 years. We sold the land in 2013. Since then, I have been immersing myself in permaculture in any way that I can. I've done many permaculture convergences and gatherings. I've done presentations on various levels of the work that I have done in these things. And then last summer, I came down to Southern Oregon to take a straw bale workshop and discovered a whole area, the Applegate, that was full of small communities. Groups of people that were gathered together for one reason or another to live on the land, to farm the land, to build, to do things. And I went, all right, it is happening. The collective does exist. And it's gotten me on this path that I am now. So I'm back in Southern Oregon, back up a little Applegate at the moment, and I am searching out people who are doing permaculture projects, living in community, intentional or unintentional. And I'm doing a series of interviews. My intention with this is to basically alert the world to the fact that people are still looking to live in community, still trying to figure out how we can pool our resources and energies and our passions and make things happen. And I'm seeing it happen, and it's really exciting. So I'm launching a video blog here. It's an effort on my part to seek out these groups of people and communities, find out what's working and what isn't working. Because the failure rate in intentional communities is running about 90%. And it's been like that from the get-go, from the early 70s when the commune and the back to the lander started happening. These communities, they've come and gone for various reasons. And it's usually the same group of reasons. It's debt, it's isolation, it's personalities. It's the inability for people to actually understand what it takes to live together and live on the land. And going into it with an idealistic and romantic notion of what can be. And then realizing in order to get there, it's going to take a lot of work. So, my thoughts on the matter are, so there are a lot of people out here doing this. But they're scattered. They're isolated. They don't know about each other for the most part. Some extent yes, some extent no. I've discovered since I've been down here a couple of places, Tequilma and Williams, Oregon. Both were started in the late 60s, early 70s as basically hippie squatter communities. And they have since become the mainstream in the places that they're living. Their kids are still there to some extent. People are still coming and going, and it's evolved into another thing. I'll have more on that later. For now, I have started out with an interview with Jim Rylands of Many Hands Builders. He is a builder that is focused on water catchment systems and straw bale construction. And so I've had the opportunity to start this process with a very articulate and intelligent guy that has had a lot of experience in this work. And the first two episodes actually, will be on Jim and the work that he's done on his own place. So please join me. Enjoy the video, and we'll go from there. See how this all shakes out over time. Thank you.
The plan view of the square foot of the roof space, and you multiply that times 0.623. That's the number. That's the amount of gallons, 0.6 of a gallon that'll fall on that square foot, on each square foot per inch of rain. So you take your square footage, let's say it's 1,000 square feet times 0.623, that means you're going to get 623 gallons of water on 1,000 square feet of roof space for every inch of rain you get. So if you get 20 inches of rain, that's your number. So 0.623 times the square footage of your roof.
Cool. Thank you.
Very few gutters are only 3 feet off the ground like this. unless you clean it all out all the time, it's just going to, decompose and become a goo, which is going to go into your water tank. So it's recommended that you put on some kind of a screening device that keeps things out of the water system at the beginning. And something like this is what I initially did. It's a product from, I can't remember the company's name anymore, but it's a fibrous material. And the idea was that you pop it in your gutter, you glue it in place on the back side, and leaves will come off and just slide right off. And that kind of works. The bigger problem is that when snow comes off this roof, it tears the stuff right out.
I was going to ask what kind of glue you use. Is it just like liquid nails kind of thing?
Caulk that comes with it.
Ah, okay.
And the other problem, and the bigger problem for me, is that this material also functions like a tea bag. It holds the little bits of decomposing litter until it decomposes to the point of goo and slime, and it keeps it right in your roof, right in your gutter, so it's always there. So I don't recommend a fibrous material like this for a gutter screen. Instead, there are products like this, which costs quite a bit more, but it's a metal mesh that it won't fit on this particular kind of roof, but it fits underneath the shingle or the edge of the metal edge of the roof itself, and then this piece tucks right under the K, and then it's screwed in place. That would work, and even better than that would be a stainless steel version of it.
Oh, that sounds expensive.
Exactly. So I'm showing you not so good, somewhat better, a lot better, best. But that's if you want to keep stuff out of your tank at the gutter level, or if you want to avoid the task of cleaning your gutters out several times a year. And getting up on a ladder is something young people can do really easily. The older folks get, the less likely they want to climb a ladder that's 18, 20, 30 feet off the ground. And some of my roofs, gutters are that tall, so got to be careful. So that's how water coming off this roof gets into the system from here. I'm going to show you the other device that we use for keeping water out of the tank, or keeping material out of the tank you don't want in the tank. You can see how the acorn woodpeckers have decided that they think these are acorns, and so they stash them inside of here.
Oh, great.
Yeah, they're either practicing or they're not very bright, and I'm not going to hazard a guess as to which one that is. So this is a much less expensive route to go, but you still have to clean your gutters out, because you still get stuff up there that will decompose and get into this system.
So, quick question for you: something inexpensive like hardware cloth, like you would for a rabbit cage, would that work if you have this as well? No.
No, because it's got to be really fine. It's got to be 32nd inch window screen size.
Okay.
Otherwise, you're going to get pine needles. That pine tree right there, it's 50 yards away from the house. I find pine needles stuck in our gutters all the time.
I'll be darned.
And it's just blowing uphill and into the gutters.
Yeah.
And that stem size will just sit right in that inside of that screening unless it's pretty fine. So this is a device that costs about $30, maybe $36 delivered. You have to order it from a company. Sits on top of a standpipe, elevated off the ground significantly so you don't get dirt splashing into the screen and then down and getting flushed into your water supply. And then the water just comes down, and at every one of these downspouts, there's one of these downspout filters. You can see this green stuff in here. That's all coming from what's sitting up in my gutters from that fibrous material that just has stuff decomposing all the time.
Right.
So not expensive, last for probably 10 or 15 years, especially if you paint them. They come white, but that PVC will crack if it gets too much UV radiation. So I paint all that stuff.
So like a latex paint is enough to stop the UV?
Yeah, you get 2 layers on there, coat of primer and a coat of color latex paint to match whatever you're trying to match. It'll last for much, much longer. Not forever, but much longer.
Right.
Yeah. So every one of the downspouts here, the projects I do outside of here, but also at this house, has or will have one of these on it. Okay, so that's at the very minimum, you should have a downspout filter to keep leaves and acorns and whatever else could fall in your roof out of the water supply. And then we'll take a walk down to where my surge tank is. When you design a rainwater system, you want to think about how much water in an hour is potentially ever going to land in your roof, and where is it going to go before it starts overflowing the gutters, because it's coming down so fast and so hard. And we live in an area where we don't have that much water coming down in a hurry. We get 1.3 inches at the most in an hour, ever been recorded in 100 years of taking measurements. So that calculates out for me to be just under 2,000 gallons of water in an hour, given the size of my roof. And so I have a 2,000 gallon surge tank. So if I had a summer downpour or a really hard spring storm, all 2,000 of those gallons wouldn't come bubbling up out of the gutters and overflow the house and just wash away. I wouldn't lose any of it. It all goes into this tank. And so if you're going to design a system that has a surge tank, size the surge tank to capture the likely maximum amount of water that would ever come down that from your roof at one time. So that's what a surge tank does. And the surge tank has a pump in it. I'll show you this. It's not required for a system, but it's a secondary filter. I got this. Now this is part that's kind of an experiment. So I've got a much larger system here. There's a stainless steel screen. The water comes out through this pipe and it goes straight through that screen, and any detritus that's on top of the screen eventually gets flushed out through this secondary pipe here. Mm-hmm. So all that water then flows into the tank itself. Right. But this is something that commercial facilities might use a much larger scale than what most homeowners are going to use, and overkill. And since I'm in the business, I happen to have access to one that I thought, cool. So what happens if the first couple rainstorms of the season, or if you have a long dry spell between rainstorms, dust and pollen and bird poop and all sorts of stuff accumulates on your roof. And the first, if you can get that off your roof and out of your water tank before it gets in the system by flushing it out a separate way, that would be better. So like rinsing the dishes before you stick them in the dishwasher, same thing. So what happens with this is that the first flush tank is sized to the size of the roof. How many gallons do you want to dispose of that have dirty water in it, mostly bird poop and pollen and stuff? And so beneath my feet, there is a 120-gallon tank that the water flows through here on its way to the surge tank. But first it goes down this T, and as that T fills up, there's a ball that floats up and seals the upper end of the T, so that then the water, as soon as this tank is filled, water then can skirt across the top of that and into the tank. So I lose my first 120 gallons every year, and that just keeps all the summer's worth of bird poop and dead bugs and everything out of the water supply.
Can you drain? Do you have a drain system for that?
I do.
Sounds like it's nutrient rich.
It is. So there's a faucet that I can put on this, but right now I'm just using a piece of wood, a wood dowel, to plug that. And that would take a couple hours for it to come out at that stream.
So you could put an irrigation,
oh yeah,
looks like a 3/4 on there, and
yeah,
and just run that down to one of the gardens?
Absolutely.
Cool.
Yeah. There's also an overflow for this tank. So if I should have a situation where more than 2,000 gallons came down in an hour, the water would flow out a 2-inch line and water that couple of trees down there, which they makes them very happy in this time of year. The white oaks particularly don't like summer water, or they haven't adapted with summer water, but they really like a lot of water in the wintertime.
So they are just adapted to just like kind of shut down during the summer? Is that what happens?
No, they don't. They're, I mean, all the species you see out here are native. So we've got white oak, we've got the manzanita, we've got all the madrones up there, the ceanothus, just everything out here. The Klamath plum is adapted to very dry conditions in the summertime. So they get their 20 inches of water during the rainy season. And then everything after that is just their roots pick up whatever they can from the soil. Mm-hmm. So if you water them out of season, you're kind of throwing their system out of whack. They just don't get it. A lot of times people will say that their oaks will die if you summer water them because the roots are going to rot. So we don't water any of the natives in the summertime. But we've got walnut trees here, which do need water, and a whole bunch of fruit trees and berries and whatnot. All right, so this is an in-ground 200 or 2,000 gallon concrete tank. Typically they're water tanks that are used for wells. Ours just happens to supply our larger ferro-cement tank with water from the roof.
You got a pretty good load there already, and it's
there's probably 800 gallons in there. So what you see there is a float switch. As that bobber floats further up, it triggers a sensor which causes a pump to turn on, and then water then flows out this pipe right here and up to the larger storage tank. Now, if we thought this through, and our ferro cement tank wasn't already here when we built the house, we would have built the house above the tank, had all the water drained by gravity into the big tank, and then had our garden below that, so that all the water could just feed by gravity into that without having to do any pressure, any electrical, anything. But as it is, we have 2 electrical pumps, 2 electrical feeds, a pressure tank. It's complicated, but it happens all the time. People put a system in after the fact. They kind of go, how do you do this?
Mm-hmm.
All right,
This is where you come in, right?
Yeah, and I tell them, don't do it this way unless you have to.
Right. Well, your gardens, I see, are down below at least. You got that part right.
We could actually operate our system without the pressure tank. If electricity failed, we could run our entire irrigation system very slowly on a gravity feed only. It might have 3 pounds of pressure in it, and it would probably get enough water to each of the plants that has an emitter on it, but it might take an entire week instead of a couple of hours.
Mm-hmm.
So. Okay, back up to the tank. So it doesn't have to be videotaped, but under this pile of wood there's a valve, and that valve is where the water from the large cistern comes from. It comes actually right under your truck and down to here. And there's going to be a little straw clay building here one day. That's going to have our electric manifolds. We'll have 16 or maybe even 20 circuits on it. So all the fruit trees and grapes and the vegetables are all going to be on different circuits. And that's all going to be housed right here. Okay, so that is a 27,000 concrete water tank that was built by somebody else. At one time it had a 30 by 30 foot redwood deck on it, and we tore the deck off, repurposed all that wood for garden bed boards and other projects, and put a ferro cement cap on the roof, what's called a proper water tank roof, because what was happening with the redwood is that it was exposed to critters. Things could go in and die. So there's a lot of dead rats and things inside, lots of algae, stuff like that.
Yeah.
So we sealed the tank basically. So both the water line that feeds the inlet pipe and the outlet pipe for this tank are in this room. They both come right under through the ground here. This is the 1-inch inlet pipe. The water that's pumped up from that surge tank is right here in this pipe. And then the 2-inch line here is the pressurized water that goes back out to the garden. And because this is a pretty well insulated roof and it has almost 5 feet of water in it right now, it's pretty well moderated for temperature, because that watermark's probably right about here. This room is probably not going to freeze in it very easily, so we store our cold. This is our cold storage space as well, pumpkins and squash and such, potatoes and onions. It's 44 in here right now. Okay, so you can see that pipe comes from the ground, goes up and into the side of the tank itself, right about at this height up here inside that room. So we'll go and take a look upside in the tank.
So have you built these ferro cement tanks?
Never.
Would you?
I can't recommend it because the material costs are only slightly lower than if you had purchased plastic tanks. I'm not a huge fan of plastic, but
right.
The material costs are slightly lower and the labor is about 1,000 times more.
Yeah.
My wife and I spent the better part of 400 hours just doing the top of this tank. 400 hours.
Oh my gosh.
And that's because there's all these layers of mesh that have to be sewn together on 3-inch centers. So there's maybe 8,000 stitches, metal stitches. So you take a piece of metal mesh or a piece of metal wire and you poke it through and you twist it, cut it off and tuck it so it doesn't catch your trowel when you're later coming through to plaster it. It's a lot of labor. ferrocement tanks are popular in countries where they have not a lot of money for materials, plenty of money for labor.
Right. And labor is inexpensive.
Yeah. Okay. So, this is what our tank looks like on the inside.
Big dark hole with a lot of reinforcement.
This is not a ferrocement tank per se. The roof is ferrocement, which means it's got a metal fabric mesh of 4 layers of galvanized wires of various kinds with that stitching, and then it's got maybe a ½ inch of lime cement mortar on both sides that pressed through. And that took a crew. We had a crew of about 15 people. Lydia was on that crew doing this whole surface. But the walls of the tank itself, out here, there's 4 inches of concrete with rebar in it that, yeah, it bounces, but you won't go through.
Okay.
4 inches wide concrete wall coming up from the ground with reinforcement. Because it was done in lifts, it leaked pretty badly. So when you opened that tank and you smelled what you smelled there, that's an elastomeric membrane. I finally resorted to painting on the entire inside of the cistern because it was leaking. I was losing an inch of water a day.
Oh my
gosh. You just
gosh.
can't afford to lose that volume.
Yeah.
So we tried plastering it 5 or 6 different ways, and it just wasn't working because I think there were cold joints in, whoever built this, they had cold joints in the lifts, between lifts, and that just was a source for water to migrate through when the tank was full. So that's our system. We can collect 27,000 gallons from our roofs, which are capable of collecting closer to 45,000 gallons. And one day I plan to put another series of tanks up above here and pump water from here into those so we can actually capture all the water that comes down on the roof in an average year. But
would it be worthwhile if you put a series of tanks up there to put roofs over them that could collect and distribute to them?
Yeah, I mean, people do that, but if you have a large enough roof surface already, that's going to exceed, if your collection capability exceeds your storage capacity, which is most often the case. Most people can collect 20, 30, 40,000 gallons off of a conventional American home size. You know, when you think about small homes or more sustainably sized homes that are 1,000 square feet total, they can't collect 20 and 30,000 gallons off of a roof that size in this area, because our average rainfall just in this part of the Rogue Valley is only 19 or 20 inches. Now, if we were 2 ridges over towards Grayback Mountain, we'd be looking at 40 inches of rain. If we were up in Rouge, I guess they record 24 inches of rain. If we were down beyond full bloom, we'd be looking at closer to 23, 24 inches of rain. But right here we're at 19, so you have to work with what you get.
Yeah, I was visiting my sister over in Gold Beach, and they said they had 40 inches in December alone.
Yeah, exactly.
Which is twice as, or almost half of what they usually get in a year.
And it's only 40 miles or 50 miles away that way. It's just over the hill.
Yeah.
And it's just the way the rain, the clouds go up these valleys, and they deposit rain wherever they want. So can you put a roof over a tank? Yes, if you were really scraping to have storage, to have surface area to collect water on, you can do a lot of things. You can actually stretch out tarps and put a gutter at the bottom of them and hope the wind doesn't blow it all to smithereens in the wintertime, but you can create a rain barn that's temporary, so that up in the wintertime, take it down after the rainy season, you'll have doubled your surface size. If you have a 1,000 square foot house and 1,000 square feet of tarps, you can do that.
Mm-hmm.
But most people don't need to do that, unless they really have to get a lot more water. Yeah, and I imagine with the medical, well, not the medical marijuana, how they're affected, but with recreational growers being required to have a water right. Since rainwater is an exempt use water in Oregon, they could use rainwater, but they have to have enough of it. And if the marijuana is a thirsty crop, you might need 1,000 gallons a year. And if you have 96 plants, that's 96,000 gallons of water a year you need. That's a lot of water.